Hey everybody, this is going to be a quick video just to run you through some things about Newton's second law. And just before I start, I wanted to mention this guy here, Isaac Newton. He's a really interesting guy. He lived during the 1600s, and in fact he was a very religious man. And so when he came up with a lot of these laws, or he tried to figure out the way you could calculate things like force or acceleration, he did it because he thought that the creator who had made all the universe would have done it with order, and that things could be described using math, like the movement of planets and apples falling and hitting him in the head and all those different things. So his second law that he came up with was a law that tried to explain using numbers and calculating and predicting the acceleration of an object, or its mass, or its force, and how it related to that object. So basically, acceleration, real quick, is how quickly something can speed up, from, let's say, 0 to 10 miles per hour. That how long it takes. Like, you get a new car, goes 0 to 60 miles an hour, and what you use is the time. How long does it take for that car to go from 0 miles per hour to 60 miles per hour? And something like 4 seconds is really good, that kind of thing. Of course, mass would be in kilograms, kg, and then force, actually, which obviously related to this guy Newton. Force we measure in newtons, okay? So for this problem set that you're going to be working on, you're going to have to derive the formula, let's say, for acceleration. So looking at this, Newton was able to say that if I know two of these three things, then I can calculate the third thing, okay? So let's say, for example, that we looked at this and we said, you know what? We know that we have 50 newtons of force, and we know that we have a mass of 20 kilograms. What's the acceleration going to be? So to do that, what you would say is, all right, let's go ahead and let's actually change the order of the equation a little bit. So we're going to say, here's force, and we're going to divide it by the mass. Okay? Now, as you can see, thinking about math, you can actually go ahead and do this. So now we can say that we could calculate the acceleration if we knew that the force was 50 newtons, and we knew that the kilograms were 20 kilograms of mass. We could say 50 divided by 20 equals our acceleration, and we could figure it out. And the cool thing with this is you can totally change the order. You could say, you know what, we're actually going to try to calculate something different. We're going to say, I want to know if I know the acceleration, I know the force, how much would the mass be for that object? And this is kind of cool when you calculate like the speed of planets and things like that. If you were able to calculate the force that was being used and the acceleration of the planet, or around its sun, you could figure out the mass of the planet. It's pretty cool. So that's basically what you're going to do with this problem set. You're going to go ahead and move around the equation pieces to be able to calculate an unknown. So if we know two of the three, we can calculate the third. So at this point, I'm going to say carry on.